Welcome back, guys. So we are taking a look at experiment 3, virtual lab 3, and this is about pipettes and burettes. Now, one thing that it talks about at the beginning of this, let me share my screen so that you are looking at the same thing that I am, is the difference between to contain and to deliver. Now, glassware is either listed as to contain or to deliver. A piece of glassware that's listed as to contain will take up and measure a specific amount of liquid, but it will not deliver that specific amount. So if it's a 25 milliliter pipette, then what you will get is it will pull up 25 milliliters, but it won't deliver 25 milliliters. If it's listed as a to deliver 25 milliliter pipette, then it will pull up more than 25 milliliters and will actually deliver 25. So what happens is that it takes a specific amount of liquid to wet the sides of that pipette and to the end of it. There's a certain amount that it takes at the very end to, how do I describe that? To there's some that gets stuck in the very end of it, and it's meant to stay there. Okay, so you're not meant to blow that portion out when you deliver that liquid. Okay, it's meant to stay there. And so because of that, you have to have that liquid stay. And if you have a piece that's measured, that's listed as to deliver, that takes that into account. So it's actually calibrated to leave that there and still deliver 25 milliliters. So that's what that means. It's calibrated to deliver the 25, but that's still being present. The to contain means that it pulls up the 25, but it doesn't actually deliver the 25. It only takes up the 25. Okay, so that's the difference between those two. A couple of things that we talk about when we talk about volumetric pipettes. They deliver a precise amount of liquid. They can be very, very tricky to use if you're actually trying to use one in the laboratory. There's a lot of skill in using them, so it can be very difficult to use if you've never actually attempted to use one. There are a lot of different ways that we talk about using this to actually get this done, and it can be a bit of a bear to try and get one to work. So that is something that is, sorry, tell you, it happens every time. So it can be a bit of a bear to actually get one to be used. Now, burettes are better. They are less difficult to use, but they are still difficult to work with, because what happens when you're using a burette is that we get to this point where we're very close to the end of a titration, and the amount between not being done with that titration and being done with that titration is often a portion of a drop. And it's very difficult to deliver that portion of a drop. Okay. It takes a lot of skill to learn how to deliver that amount of liquid. And these burettes, this is the stopcock that you have. And trying to use this to be able to deliver that small of an amount can be extremely difficult. Okay, it can be done, but it takes a lot of work to be able to figure out how to do it. Okay, so it's not as easy as it looks. And it does take a lot of skill to be able to do that. Now, one of the things that we talk about when we talk about using this kind of glassware is that the diameter of that piece of glassware has a lot to do with how precise that it is. The more narrow that piece of glassware is, the more precise that it is. Because the more narrow that it is, the easier it is to see the graduations that are on it and see how big, it's the bigger those graduations are going to look on that piece. Okay, so it's easier to see how different they are. And that's useful when we're trying to get very, very small measurements. Right? So it can be very useful to have a very precise piece of glassware that's very, very thin. But they can also be very problematic if they're very thin, because they're very easy to break. So there is a risk and reward with that. So we have problems with working things that way. We have to be cautious with working with that kind of glassware. Of course, the smaller it is, the more expensive it is to produce, so, because it is often way more expensive to make. So there is, you know, some trade-off with doing it. Okay. So that's some of the practical side of that. All right. So let's talk about this particular simulation. So same kinds of things will apply that we've been talking about before. We've got to make sure that we practice with this glassware. So we're going to click on the volumetric pipette and the bulb. So pipette and the bulb. Let's pick them both up. We squeeze the bulb to get all the air out of it. We click on our hand with the bulb and place it on the pipette. We click on this to place it into the DI water, and then we pull up some water. So we're going to release the bulb to pull up some water. Then you're going to click on the hand with the bulb to remove the bulb and apply our finger. So we very quickly do that. We're then going to release the finger pressure to get this to exactly where we want it. So what we want is that liquid to be exactly on that line. And it's difficult to do. That looks good to me. So now we can take this over here and put it in here and then let go and let that come out. We're just going to let it drain. All right. That's 25. So we're going to 25.0. Don't want 2 zeros, so it's 25.0. Value 25. It's a 10 mil. Very hard to read. $10.50. There we go. Water from the flask into the chemicals for disposal. So now we'll put it in here, and then we'll put this in here, and then we can go to phase 2. Hooray! That was fun. Now we're going to Taylor balance. We're going to put this on here. Record the mass, 30.560. Let me take whatever's on there. I'm going to place the flask on the bench because we don't dispense anything onto the balance. Pick this up, we pick this up. You squeeze this again, put this onto that. You then pull this whole thing over here. We release that. Finger pressure, you want to let this go again. Get it exactly to that line. Oh, too much, so I have to reset. Isn't that great? Tear it again. I'm gonna put this back on here, 30.560. This off. This up, pick this up, put this back on here. Take this over here. That off. So I'm gonna release. Now we're gonna take this over here, do this, and take it off. And now we're gonna take this. that there. And now we're going to put this up here, 49.360. 360. And that, of course, means that the difference $40 and 360 minus 30.560, 18.800. I have 2. And the density is going to be the grams per milliliter. So I have that 18.800 divided by 10, which is 1.88. 1.88. It should be 4 sig figs because this is 4, this is 5, so 4 sig figs. And I'm going to pour this into the waste disposal, put that in there, and go to phase 3. Hooray! Now we're going to open the stopcock or DI water into that. Open the stopcock again to fill that. And filling the tip of the burette, you see an air bubble. What should you do with the air bubble? Control the flow of the liquid in the burette to keep the same size. Nope. Adjust the flow of the liquid out of the burette to remove the air bubble. So that. Continue. To close the stopcock, at your initial volume, which I see is 0.1. Take this out and put this over here. Place clean Rowan layer underneath. Open the stopcock to add 20 to 25. Close. As your final, I have 23.112, 23.3. It's It's 22.6. It's backwards, so it's 22.6. To 22.7, sorry. You can read. It's 2.60. There we go. 0.9. Serum. Bring it over here. And 5.64. Two, six. Yes. 71. 0.02. Yes, me. Okay. 34.35. 34.32. The density grams per milliliter, so that's grams divided by 22.60. 22.60. 1.52. 2. Turning 2. Is 35.352. Six. Why do I keep calculating the wrong thing? Okay. The mass of my solution is 34. So I'm going to divide that by the volume of the solution. Deliver 22.60. 1.52. Right number of sig figs is 4. That's why I didn't get it right. Okay. Then I'm going to do this, this, that there, and this. Do that. And then I'm going to there. Print this. This in the same place that I put the other ones. and then that'll be good.